Good evening, everyone. Am I audible?
Yes, madam. Good evening.
No.
Yes,
Good.
ma'am.
Okay. So in today's session, we are going to see all topics from week 3. Okay. Fine. So in week 3, we are going to see first what are frequency tables. So frequency table can be made for either discrete data or continuous data. Okay. And then we see some graphical summaries on how to get this summaries from the frequency table. Okay. Once we understand how to make graphical summaries, the next step is to see some numerical summaries. So these are the topics we are going to cover today. So a quick recall on the types of variable, right? So what are the different types of variable we already know? We know that a variable can be categorized as either a numerical variable or a categorical variable, right? In other words, what is the other term for categorical variable?
Qualitative value.
Quantitative.
Right? And for numerical?
Quantitative.
Quantitative.
Right? And then again, the numerical value can be further classified as discrete or continuous, right? So this is something we have seen earlier. Okay. Now let's recall what is meant by a discrete variable. A discrete variable means usually it involves a count of something, right? So we can count something. Whereas a continuous variable usually involves a measurement of something, right? So for example, we can count the number of students in class. And then for measurement, we can measure the length of a paper or length of a object or something like that, right? So you know what is discrete and continuous. Okay. So just to check whether you remember it properly, few quick exercises here. So suppose one is interested in calculating the weight of a bag in kg before leaving for the airport. What kind of variable is the weight of the bag? Quantitative and discrete?
Quantitative.
Option B. Option B, ma'am.
It is quantitative and continuous, right? Okay. Okay. What about the next exercise? Number of days a group of students take to finish a school project is a what kind of variable?
Option D. Option A.
Option
A.
Quantitative and continuous.
Quantitative and continuous?
Discrete, sorry.
Yeah. Okay. The next exercise. What kind of variable is latitude?
Continuous.
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 Continuous and numerical.
A and C.
When you say numerical, it would always be
Right. So numerical and continuous. Right. Okay. So it means you are able to recall these concepts. Okay. So now let's see how to organize discrete data. Okay. So first let's see some simple examples. Now here, if the data set contains only a relatively small number of distinct or different values, it is convenient to represent it in a frequency table. Example, here you see each class represent a distinct value. That is a single value along with its frequency of occurrence. For example, you see here the number of books read by 12 students in a month is given below. Okay, so this is the data set. So you have 0, 2, 1, 3, 2, 4, 1, 3, 2, 0, 3, 4. So what you see repeatedly only few numbers are repeating again. What are the few numbers which are repeating again and again?
1, 2, 3.
2, 3, 1, 4.
0, 1, 2,
0,
3.
1, 2, 3, and 4.
Okay, so you see that specific values are repeating again and again. In this kind of a scenario, we can easily represent the given data using a frequency table. Okay, so now for making a frequency table, so the first column usually contains what are the distinct values in the given data, right? So here the first column is the number of books which contains the distinct values 0, 1, 2, 3, 4. Now we are going to calculate the frequency of each data. So now each distinct value. So now for 0, how many distinct values are there? 1
2.
and 2, right? Okay. Now for 1, how many distinct values are there?
2.
2.
1, 2. Okay. Now for 2, how many distinct values?
3.
3.
1, 2, 3. Okay. Next for 3,
3.
1, 2, 3. Okay. Next for 4, how many?
2.
2.
So now if you sum this, what are you getting? What is the sum of all frequencies?
It is 12.
12.
12, right?
12, ma'am.
So 2 plus 2, 4, and then plus 3, 7, and plus 3, 10, plus 2, 12, right? And you see this is matching with the given number of nodes. And hence the frequency table we have made is correct. Okay. So one small cross check to see whether we have not missed any values. Okay. So this is a simple frequency table. Okay. Now, instead of a discrete data like this, suppose we are having continuous data, it is going to be a little more involved in this case. Okay. So now next step is how to organize continuous data. Okay. Now organize the data into a number of classes to make the data understandable. In this case, it is now continuous. So for continuous data, we are going to classify the given data into different classes. Okay. So following are the few guidelines we are going to follow to make the classes. Usually the number of classes is not something fixed. So here usually we see that the number of classes vary between 5 and 20. Okay, so for exam purpose, you will not be asked to do this proper classification of the continuous data. Okay, so don't worry about how to exactly figure out the number of classes. So, but you should know that the number of classes are usually varying between 5 and 20. Okay, and the next important thing is that each observation should belong to some class and no observation should belong to more than one class. So you see that you take any value. Suppose let us say there are like 5 classes, class 1, class 2, class 3, class 4 and 5. Okay, so now in this case, each value should belong to exactly one class only. Okay, you cannot have some value which belongs to both the, any two class. Okay, that is not possible. So any value should belong definitely to one class and only one class. Okay, only that is possible. Data cannot belong to more than one class. Okay, and it is common that we choose the class intervals of equal length. Okay, so each class is of say the interval length for each class is of same length. Okay, so here are some important terminologies. So maybe to understand these terminologies, we will see this example and then we'll come back again. Okay. So now here you see the marks obtained by 50 students in a mathematics course is given below. Okay. So you are having 50 data points. So obviously you can see that this is not a discrete case because in the discrete case we were observing that the number of values were very few and they were repeating again and again. The distinct values were very few and they were repeating again and again. That was discrete data. But here you can see obviously that you cannot see very few numbers. There are a lot of numbers and they are not again repeating. So it is varying between certain range. Okay. So first of all, to understand the range, we have to see what is the minimum value and maximum value. Can you all figure out what is the minimum and maximum value in the given data set?
Minimum is 50.
Minimum is?
Maximum is 99.
Okay. So minimum is 50. Okay. So this is your minimum. And maximum is
99. 100 is excluded.
99.
99. Okay. So this is your maximum. Okay. Okay. So your values are varying between 50 and 99. Okay. So now to make the class interval, you know that all values starting from 50 should be there and all values till 99 should be there. Okay. So the class interval should cover all the values between 50 and 99. That is the first thing you observe. Okay. So the next thing is that, so now in this case, how many classes do we have?
5.
So this is first class, second, third, fourth, and fifth. Okay. So now you see that these are the 5 classes. Now, each of these classes, you see now 50 to 60, 60 to 70, like this it is given, right? Now, what is mean by the lower class limit? So these are the terminologies which I told we will be seeing after this example. So now let us try to understand. What is the lower class limit? The smallest value that could belong to a class. Okay, so for example, if you take the class 50 to 60, the lower class limit is 50. Similarly, for 60 to 70, the lower class limit is 60. Okay, fine. So what is the lower class limit? That is very clear. But upper class limit, you have to be a little bit careful. So before you go to the upper class limit, let me ask how many of you know the meaning of this? So let's say 50 to 60, if I represent it in terms of interval like this, do you understand? What is the meaning
Yes,
of it?
ma'am.
50
Meaning
included,
of
60
this,
not
50 is
included.
included, 60 not
60
included.
is
Included and
excluded.
60 is excluded.
Exactly. Okay. Similarly, 60 to 70 means,
Some 60 is included and 70 is excluded.
yes. Okay. So you should understand it in this way. Okay. So let us for now assume that you are having only integer values. So if you are assuming that the given data set, you can obviously see that this given data set is having only integer values. So in that case, according to this definition, the largest value that could belong to a class. So what could be the largest value that could belong to the class 50 to 60?
59.
59.
9. Okay. So you should understand it this way. So the upper class limit in this case is 59. Similarly, for 60 to 70, the upper class limit is 69. Okay. And the next important terminology is class width. Okay. So this is something we discussed earlier. So what is class width? The difference between the lower limit of a class and the lower limit of the next higher class. That is the class width. For example, so here you see lower limit of next class minus lower limit of current class. So 50 to 60 to 60 to 70, the class width is 60 minus 50, so which is 10. And this is what I said, we discussed this earlier. All classes have same width, which is 10. So this was the point we told here as a guideline, right? So all class intervals are of equal length, right? So remember that the classes are having interval length 10 here. Okay. And the next terminology is, okay, so this is not more terminology, but inclusion. So this is again something we are repeating. So what is this inclusion? A class interval contains its left end, but not its right end. So in the sense that if you take 50 to 60, it means you are having 50 less than or equal to x less than 60. So 60 to 70 means 60 less than or equal to x less than 70. Now, for example, suppose you are having one data point, which is 60. Will it belong to this class or this class? First, let's call this first and second. Which class will it belong to? The data 60.
Class 2.
Second class.
Second.
Class second.
So 60 should belong to this class, right? And 60 does not belong to this class, right? So this you should keep in mind very clearly. So 60 does not belong to first class and 60 belongs to the second class. Okay. So with this understanding, now let's complete this frequency table. Okay. So now this frequency table, so we are going to use tally because it helps us to verify. Okay. So how are we going to use this tally? So now let's calculate now. Sorry. Let's check each value one by one. Now first value is 72. So 72 belongs to which class?
72
Third.
Third class. Okay. 85 belongs to which class?
Fourth.
56 belong to?
First class.
98 belongs to?
Last
Fifth
class.
class.
67 belongs to?
Second class.
Second class.
50
second class.
belongs to?
First class.
First class.
73 belongs to?
Third class.
Third class.
62 belongs to?
Second class.
88 belongs to?
Fifth class.
54 belongs to?
First class.
First class.
95 belongs to,
Fifth class.
Fifth class.
60 belongs to,
Second class.
Second class.
77 belongs to,
Third class.
Third class.
69 belongs to,
Second class.
Second class.
81 belongs to,
Fourth class.
70 belongs to,
Third class.
class.
68 belongs to.
Second class.
Now, here everyone listen. So once you are done with 4 lines here, the 5th line goes in this way. So it is easier to calculate in terms of 5, right? So you can add 5s easily. So that's why this kind of notation. So after 4 lines, the 5th line is like this. Okay. All right. Now 57 means which class?
First class.
First class.
93,
Fifth class.
Fifth class.
61,
Second class.
Second class.
52,
First class.
First class.
65,
Second class.
Class.
and then 79,
Third class.
Third class.
55,
First class.
First class.
83,
Fourth class.
Class.
55,
Second class.
First class.
63,
Second
class.
class.
75,
Third class.
Third class.
58,
First class.
66,
Second class.
Second class.
71,
Third class.
Third class.
64,
Second class.
59,
First class.
First class.
99,
Fifth class.
Class.
78,
Third class.
82,
Fourth class.
Fourth class.
60,
Second class.
74,
Third class.
Class.
53,
First class.
First class.
80,
Fourth class.
Fourth class.
67,
Second
Third
class.
class.
50,
First class.
First class.
68,
Second
Second
class.
class.
70,
Third class.
Third class.
76,
Third class.
Third class.
84,
Fourth
Fourth class.
91,
Fifth class.
Fifth class.
Fifth class.
95,
Fifth
Fifth class.
Fifth class.
81,
Fourth class.
Fourth class.
92.
Fifth
Fifth
class.
class.
Okay. So now from the tallies, you can tell the frequency. What is the frequency for the first class?
11.
11. Second,
13.
third class,
11.
11.
for fourth,
8.
8.
for fifth.
7.
7.
What's the sum of all the frequencies?
50.
50.
So sum is 50. Right? Okay. So that should match with the given number of data points. Okay. Fine.
Ma'am,
Yes.
ma'am, I had a general doubt. Can I ask now?
Is it in this topic we are discussing here or something different from this?
Ma'am,
it is-
related to the topic only.
Relating to?
Ma'am, related to topic only. Ma'am, quartile reasoning
me.
regarding to it.
Yeah.
Actually, ma'am, if the observation comes out to be, for example, 1.25, like
Hmm.
less than 0.5. So, ma'am, which observation to take? The first one or the second one?
It depends on what is your class interval, right?
No, ma'am, I am asking regarding like for example, the observation came out to be, it was regarding interquartile range actually, this question.
What range?
Interquartile range.
Oh, interquartile range we are going to cover a bit later. Okay, I will explain at that time.
In the last
Okay,
part, I
ma'am.
think
Yeah, we will cover that later. Okay.
Okay, ma'am.
Excuse me,
Okay.
ma'am.
Yes.
Ma'am, here, like we see that 50 to 60 or 60 to 70, that's a uniform distribution, right? Like the upper limit for the previous class is the lower limit for the second class.
Yeah, kind of. Yeah.
But let's say if the distribution is not uniform, I mean 50 to 61.5, let's say, and the next class starts from, let's say, 62 to 70 in some case. So in
We
that case,
usually don't do that. That's what is the third point. So usually we make the class intervals of equal length. So don't worry about unequal class length. So this is something we are going to follow in this course. So we are
Oh.
going to only consider equal length.
okay, ma'am.
Okay.
Thank you so much.
Yeah.
Ma'am, that is class width.
Yes. Class width is say equal. Yes.
Okay, ma'am.
Yeah.
Ma'am, where we get this PDF?
Yeah. So it will be available in the supplementary content in the portal.
ma'am, what is class marks?
Class marks. Where is class marks? What? Which one you are asking?
There is a term ma'am is talking.
Okay, here this one. So class mark is the average of two class limits of a class. This is used much later. Okay, so when we are going to find mean of continuous data, so in that case we use this class mark. So class mark is the average of two class limits of a class, right? So for example, if you have 50 to 60, then it will be 50 plus 60 by 2. So we will see how to use this class mark a little later. Okay, fine. So for now, this information is enough to make a frequency table. So how to make a frequency table for a continuous data? Is that clear for everyone?
Yes.
Yes, ma'am.
Yes,
Oh.
ma'am.
Okay, so once we have the frequency table, the next part is, can you guess what is the next part? We have just seen what should be the next part in the first page. Can you guess? The
Relative
next part?
frequency.
Yeah, relative frequency.
Graph.
You have to find the midpoint, like 50 to 60, the midpoint, and then multiply the frequency with it.
Yeah, so the next part should be histogram now. Okay, so there can be relative frequency or someone mentioned midpoint, but now we are going to see histogram. Okay, the graphical representation. Okay, is what we are going to see next. Okay, fine. So, how to make a histogram? Again, the steps, what are the steps given here? The first step, obtain a frequency distribution of the data. So, first step we have already done. Right? We made a frequency distribution. The next step is draw a horizontal axis on which to place the classes and a vertical axis on which to display the frequencies. So, this horizontal axis. So, this is your horizontal axis. So, the horizontal axis, we are going to keep classes. Right? And the vertical axis, this is your vertical axis. The vertical axis, we are going to keep frequencies. Okay, fine. What is next? For each class, construct a vertical bar whose height equals the frequency of that class. Okay, so now what are we going to do? How many classes we have in this case? I guess there is a mistake in the data. Just a minute, I'll correct this data. So here it should be 11 and here it is 7, right? Okay, so here this 5 classes, first let's mark them down. So first class is 50 to 60, right? So this class is 50 to 60. And then this is 60 to 70. And then 70 to 80, 80 to 90, 90 to 100, right? So these are the 5 classes if you remember. Right? Okay. Now, in the first class, what is the frequency?
11.
11.
Right? So in the left hand side, where is 11? So 11 is here, right? So let's make a vertical bar, maybe some other color. Okay, so this is 11. And for 60 to 70, it is 13.
13.
So 13. Okay, next again 11. And then it's 8. And then 7. Okay, so usually you shade them or you fill them with colors or fill them with some patterns. Okay, you don't just draw the outlines, you usually fill them with either some solid colors or patterns or something like that. Okay. Okay, so this is our histogram. So did we do all the steps? The second step we had the horizontal axis and vertical axis. Third step, we constructed vertical bars whose height equals the frequencies. Fourth step, we label the bar with the classes, the horizontal axis with the name of the variable and the vertical axis with frequency. Did we already label the bars with the classes? These bars are labeled with the classes, and you see in the vertical axis, we mentioned that it is frequency. So all the steps are done. So is it clear how to construct a histogram from a frequency table? Is that clear for everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
Ma'am.
Okay.
Okay.
So one important difference is here. Okay. So recall,
Yeah, ma'am.
if you have a bar chart, for example, you see the favorite fruits or something like that you might have seen. So let's say you have like apple, orange, banana, something like this is there. And then the frequency table are usually something like this. So you have something like this, something like this, something like this. So some numbers are like this, right? So this is how you have a bar chart. And bar chart, they are representing discrete data, right? And see, you have the classes are just standing somewhere independently. But here, the important thing is that in histogram, no gaps between the vertical bars. Okay, so this is something important. Okay, so you see the next bar is just starting where the previous bar ends. So there is no gaps in between the vertical bars. This is something very important. Okay, clear? Okay. So the next thing is another graphical representation which is called as stem and leaf diagram. Okay, let's see how to make a stem and leaf diagram. The usually commonly used graphical method is histogram. Stem and leaf diagrams usually these days, at least to my knowledge, it is used in courses like this. Okay, so stem and leaf diagram is not used by many people. Okay. Unless they want to know what are the values belonging to a class, stem and leaf diagram is not used. Okay, what I mean, you will understand now. So in a stem and leaf diagram or stem plot, each observation is separated into two parts, namely a stem consisting of all but rightmost digit and a leaf, the all but rightmost, and the leaf should contain the rightmost digit. For example, you see here this data is here. This data you see 12, 18, 21, 27 like this you have data, right? So in this case, what is the rightmost value for 12?
2.
2 is the rightmost value,
2.
right? So 2 is the rightmost and hence this is your leaf. Okay, and the other value 1, that will be your stem. Okay, now suppose you are having some other data like this. Suppose let us say you are having something like this. Let's say 1992. It is maybe the data is about years, let us say. Okay, 1992, something like this. In this case, what will be your stem and what will be your leaf? Can you tell?
Stem will be 19 with the leaf and 9 will be the stem.
See the rightmost digit. What is the rightmost digit?
2.
2.
2 should be your leaf, and whatever is remaining, so all but the rightmost digit, the remaining, that should be your stem. Okay, so how to make the stem and leaf in the given data, is that clear?
Ma'am,
Yes,
what
ma'am.
about 10?
Yes, ma'am.
Ma'am, what about
What
10,
what
20,
about
30?
in 3 digits?
What about 3 digit? You again tell. Suppose you have some digit.
The rightmost one.
Yeah, so again you see 3 is the rightmost, this is the leaf, and then this is the stem.
Ma'am, what about 10, 20, 30?
That is what we saw here, right? The rightmost value, the last value will be your leaf, and the left value, the remaining values are going to be your stem.
Ma'am,
So
if it
zero-
was a
so
single
zero-
digit, then stem
zero
will be
will be-
0, right?
Sorry, what?
Ma'am, 0 will be stem.
See, if you are having 10, it does not make any difference. This is your rightmost value. So 0 is going to be your leaf, and 1 is going to be your stem.
Ma'am, what if we had single digit values like 1, 2, 3? Then 0 will be stem and the other digit will be the leaf.
So usually if you have single digit, then you don't use a stem and leaf plot. So stem and leaf, at least 2 digit values you need. So otherwise a stem and leaf plot will not make sense. Okay.
Okay, ma'am.
Yeah.
Ma'am, if 2-digit value given in point, so
Sorry, what?
ma'am, if data given in decimal value.
Decimal values are something which we usually don't represent using stem and leaf. So better whenever you are having decimal class, stick to histogram. Okay, so we usually don't use stem and leaf where you have decimal values and all. Okay.
Okay.
All right. Okay, so the first step, I hope it is clear. The second step, write the stems from smallest to largest in a vertical column to the left of a vertical rule. Okay, so let's try to understand step 2. Okay, so first step we understood. Now, what are we going to do? Write the stems from smallest to largest. First of all, what are the stems in the given data? Let's try to understand. What are the stems in the given data? Can you tell me?
1,
1,
2,
2, 3,
1, 2, 3, 4.
3,
4.
4.
Okay, so let's try to write the stems. So we have to write them from smallest to largest in a vertical column to the left of a vertical rule. Vertical rule means just a line, vertical line. Okay, so we are going to draw a vertical line. And on the left side, we are going to write this stem values from smallest to largest. Okay, so these are the stem values. And the leaves, how are we going to write? So now the leaves, what is the first data? So let's see what is the step 3. Write each leaf to the right of the vertical row in the row that contains the appropriate stem. What does it mean? So this means that first, what is the first data?
12.
12.
12. So the leaf is 2.
2.
Similarly for 8.
8.
8.
Okay. And for 21,
1.
27,
7.
5.
7.
5.
1, 5.
3, 3, 5.
4.
3,
3. No, ma'am.
9.
21 itself, there is the 2 more.
Let's do one by one. Let's do one by one. After 34,
9.
39.
39. And then 25.
5.
And then
42.
42. 2.
and then
31.
3, 1.
Ma'am, 31.
And then
For 3 we have
29.
9.
23.
46.
46. So leave 3.
and then 23.
3.
Okay, so there is one thing very important. Everyone listen to this point carefully. When I
Shouldn't
wrote
be
this,
25 come before 27?
I have not yet come to that part. Let me just say this point first. See, when I made this stem and leaf plot, be very careful that when I'm writing it, I did not write it like this. 2, 8, 1, 7, 5, 9, 3, 4, 9, 1, 2, 6. I did not write like this. But I wrote it very carefully such that the values are in a line. Okay, the reason for this you will understand shortly. So this is step 3. So the step 4 is what someone asked. Arrange the leaves in each row in ascending order. Okay. So the step 4 is this. So what we are going to do in step 4, whatever we have done here, just the leaf part, each leaf we are going to arrange in ascending order. First is already in ascending order. Second, we have to arrange it in ascending order. 1, 3, 5, 7, 9. Third one, 1, 4, 9. And then fourth one, 2, 6. Okay, so this is our final stem and leaf plot. Okay, so for example, here usually we write something called a key to understand what is this representing. So for example, here 1, 2, what does this 1, 2 represent?
One is the stem.
Should we mention the key?
Yes, so usually we are not in this course, at least you are not going to draw a stem and leaf plot. It is going to be given, and then from that you are going to get some questions. But just to know this, how to make a stem and leaf plot, this information is important. So how to make a key? So for example, this 1, 2 represents this data 12. And what is this 12 representing? 12 is the age, right? Age of participant attending a health awareness camp. So 12 represents the age 12 of a, this is a participant, of a participant. Okay, so this is usually how someone writes a key. Okay, you don't have to bother exactly how to write key, because these are some things usually given. But you should know that every stem and leaf plot contains a key like this. Okay. Now coming to an important observation here. Okay. So everyone, now you are going to view it. I'll see if I can turn this page view. Just a minute. Yeah. So this is how I want to. Yes. Okay. So now in this view, why this view? I'll tell you now. Sorry. So here you see that now suppose I am going to make it like this.
Ma'am, can it be done on landscape mode? Very problematic.
No, just to see this, how this graph is looking, just to see that.
Okay.
Okay. The view is anyway coming for you like this, right? Okay, fine. So do you see that it is looking like a what?
Chart.
It is looking like a
Histogram.
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 Right?
Vertical
Now,
histogram.
what is histogram? Each of this is now a class. So this is like class 1, class 2, class 3, class 4. Right? You see the first and second, first and last. Where is the page? Sorry. So you see the first and last class are having the same sizes, right? And then the second class is the one having highest length. And then you see the third class is a bit higher than the first and fourth. Okay, so this is usually you can how you can compare it with the bar histogram. Okay, so stem and leaf plot are not very much different from a histogram. You can observe how it can be related to with a histogram. Okay, so that is why the way you are going to write the numbers is going to be important. Okay, so if you are not going to follow this order, like writing it exactly below, like this I mentioned here, so you will not get this exact histogram. The sizes will vary then. Okay, that's why you have to write it in this way. Okay, fine. So the next part here, so is the stem and leaf plot first of all clear for everyone? Any questions in stem and leaf?
No, ma'am.
No.
Excuse me, ma'am.
Yes.
Ma'am, can you please repeat the part where, like, you showed now one with two, we have so many values. Like, how did you do it? Like, if with a single stem we have multiple leaves. Once
Yes.
again, that part. Can you please explain that? I couldn't hear.
So you are asking like 17593. How did I
Yes,
write here?
yes.
So I'm just writing whatever is this value. So take any data. So if the data is containing the stem as 2, then I write the remaining part, the remaining leaf part here. Similarly, for this, the stem is 2, so that I write the leaf part here. Same way I do this for every data. That's all. Nothing big here.
Okay, ma'am, got it.
Okay. Okay, so now we are done with how to do a histogram and a stem chart. So now we are moving to descriptive measures. Okay, so these descriptive measures are quantities whose values are determined by the data. Most commonly used descriptive measures are categorized as measures of central tendency and measures of dispersion. Okay, so measures of central tendency, these are measures that indicate the most typical value. Okay, so in some sense it is typical value, or in some sense it is center. So you can understand it from the different measures. Okay, and measures of dispersion, of course the word tells you how much the values are spread across. Okay, the variability of the data set. Okay, so let's try to understand this in detail. So the first measure of central tendency we are going to see is mean, which you already know, the average, right? The word mean refers to just the average, right? And you all know how to calculate the average, right? So how do you calculate the average? Whatever is the data set, you add all the values and divide by the number of data, number of observations, right? So here you see that if you have a sample mean, it means that the n you are considering here is the sample size. So here usually this is the notation. N is the, small n is the sample size and capital N is the population size. Okay, fine. So a very quick problem. So everyone keep your calculator with you ready. Can you all quickly do the sample mean for this data? So here, what is the value of n here?
10.
How many? 10. Okay. So what is the sample mean? So you calculate the mean here. So what is the mean?
Ma'am, in the exam, are we allowed calculators, ma'am?
You will be given a calculator in the portal itself. You will have a calculator.
Okay, ma'am.
Ma'am, answer 68.
68 also.
68, ma'am.
67.5.
Right. Okay.
By 10, 68.
Yeah. Okay. Fine. And then, so this is the simple average. Now, suppose you are having a group data, right? Now, suppose you are having something like this, then how do you calculate this? So this is the frequency table for a discrete data. Now, for this discrete data, so you are already having the frequencies and the corresponding values here. So you are going to make another table, another column in the table, which is Fi into Xi, product of the value with the frequency. So this way, you are just So this is a simple logic, right? So how many times 1 is appearing? 2 times. So either you do 1 plus 1 or you do 1 into 2. Both are same, right? So here what we have done, 1 into 2, which is same as 1 plus 1. Similarly, here what we have done 2 into 3, which is same as 2 occurring 3 times. Right? Same way 5, how many times it is, 3, how many times it is occurring? 3 is occurring 5 times. Right? So you are having something like this. So you see what is this fi into xi? Why are we doing this? So instead of just adding them, if you multiply this, you will get the answer quickly. That's it. Okay. So now you see that this summation fi xi. Okay. So this is summation fi xi and this is summation fi. So what should be the mean value? Mean value is simply summation fi xi divided by summation f. Because what is summation fi? That should be the sample size. Right? So in this case, can you quickly calculate and tell me what is the mean value?
2.9.
2.95.
2.9.
5.
5 or 3 or what is the correct value?
2.93. 2.93.
Okay.
2.93.
Okay. So this is the value for, this is how you calculate the mean for group data in the case of discrete scenario. Now how to do it for continuous case? Okay. So now for continuous case, now you see that you are not having the exact values. You are just having the class intervals in each case. What are the exact values will vary. So your exact values may be something like this, right? So so remember, this is a very important note here. Note, this is an approximate value. Why? Because we are not considering the actual values. So these are the actual values. We are not considering the actual values. We are just considering the class intervals here. Okay. And this is the class mark which someone asked earlier. So here we are going to use the class mark. So how to use the class mark and how to calculate it. Okay. So very simple. So class mark, as you said, so it is the average of the lower limit and upper limit here. So 50 plus 60 by 2. So what should be the answer?
55. 55.
What about 60 to 70 then?
65.
65.
65.
75, 85, and 95.
Adding 10 both.
Can you calculate fi into mi?
Yes, ma'am.
Yes, tell the values. What's the
565. The first one.
605.
845.
150.
This is 11 and this is 7. 11 into 75.
825.
680.
68.
660.
Okay. Now calculate sum of all fi mi. So remember, this is class mark. So what is the sum?
3620.
So what should be your x bar approximated mean? 3620. By this is your sum of frequencies, which is the size of the data set. So the value is approximately
72.4.
Okay. So here the average is an approximate value and it is not an exact value of the mean. Remember that. Okay. Okay. So here something.
Hello, ma'am.
Yes.
I have a doubt in this. For this data, we have suppose like some inferential statistics.
Mm.
There is a chance of any error.
Mm. whenever you are approximating, yes, there is some error automatically. Okay. Inferential statistics always has error. So zero error means the data is too ideal. We never have 100% ideal data, right? So in practical scenario, zero error is very, almost impossible, you can say. Maybe not even rare, almost impossible, we should say. Okay, fine. Okay, adding a constant here. So what does it mean? Suppose the given data set, I'm going to suppose, let's say each student, the whatever scores we saw earlier. Now suppose the teacher adds 4 marks to each student. Now how is the new mean related to the old mean? How is the new mean related to the old mean? Suppose I call the new mean as y bar and the old mean as x bar. How is x bar and y bar related if I am adding a constant c?
Y bar equal to x bar plus the constant.
That's it, right? So you don't have to again do all the calculations. Simply you can do y bar equal to x bar plus c. So here in this case, so what is the x bar value? Did we already calculate it somewhere? I guess this is not calculated. Can you quickly calculate what is x bar here? It is 620 by 10. So it should be 62. Okay. And here, what is the new data set? Your new data set is 59, 66, 52, 74, 69, 64, 62, 76, 67, 71. This is your new data set, right? So your new mean, okay, so I will leave this verify. Y bar equal to whatever is the value. So I am not going to calculate it in the traditional way of computing average. New mean, I am just going to apply the formula y bar equal to x bar plus c. So here, what is your x bar? X bar is 62 and
62.
c here is 4.
4.
So it is 66. Okay, so verify your y bar using data. Okay, so verify this part later on. Okay, so you can clearly see that this will match with this. Okay, now this is about addition. Now what will happen if we are multiplying instead of adding?
Y bar equal to x bar into c. Constant.
That's it, yes. So your new mean will be just c times of x bar, right? So now here, suppose the teacher has decided to scale down each mark by 70%. What does it mean? We are in multiplying each mark by 0.3, right? So in this case, how are the new mean and old mean related? So we have already calculated the old mean, which we know is 62. So what should be your new mean?
18.6.
0.3 into 62, which is 18.6. Okay, fine. Okay, now moving to the other measure of central tendency, which is called the median. So while defining central tendency, we saw a typical value or the center of the data set, right? So typical value is what is the average. But if you are looking at the center, then that is median. Okay, so where position matters, where the position of the data matters, then in that case, median is the central tendency we are using. Okay, so for example, so here, first of all, what is median? Let's try to understand, then we'll move to examples. The median of a data set is the number that divides the bottom 50% of the data from the top 50% of the data, right? So the median of a data is the middle value in its ordered list. This is again very important. Sorry. Yeah. Yeah. So
I have a question regarding median.
yes.
In the salary, when it is talked about salary, why median is prioritized than mean?
In salary, why median is used instead of?
Why median is prioritized more than mean?
Okay, so for salary, why median is used instead of mean? But
No,
usually,
both are used, but why median is prioritized?
I don't think median is prioritized, but if the salary contains like outliers or extreme values, in that case, maybe median is a suitable candidate compared to mean. So it depends on the data set. So suppose the data set is not having any outliers and the data are evenly distributed in a reasonably good range, then maybe mean is a better candidate for salary. But if the data is having many outliers, which is going to definitely affect the mean, then in that case, median is more suitable. It depends on the data. Okay?
Hello, ma'am.
Yes.
I have a doubt regarding this. If in a company there is suppose 3% salary is 6.5 lakhs per annum, and 2 is 5 lakh per annum, and 4 is 6 lakh per annum, and there is a CEO whose income is 1 crore per annum. Then what should be prioritized, ma'am?
As I told you, so here there is an outlier which is going to definitely pull the mean towards it, right? So whenever there is an outlier, better to avoid mean. Mean is very sensitive to outliers, so in that case, it's better
But
to
there,
value.
ma'am, but there is suppose the most number of employer is in 6 lakhs per annum. So why I can't prefer mode?
Yes, mode can also be used in this case. Mode is also fine, median is also fine. But again, we have to be careful. So suppose, let us say there are, I don't know. So again, it depends on the data set. So median.
There is their data something like that in a question. So yes. And
Okay.
their option is
in such
the answer
case,
is median.
Median is actually whenever there is an outlier, one thing is that so median is more robust to outliers. That is always there. Whenever there is an outlier, it is very safe to consider the median. That is the first thing about considering a median. But if it is if you are asking why not mode, yes, mode can be also a suitable candidate, but it comes next to median because of the thing that mode is also possible that it is also affected by outlier in certain scenarios. It's not wrong to consider mode depending on the scenario, but as I mentioned, median is the more robust measure of central tendency whenever there is an outlier. So if you have an outlier, better choose median. The other thing is that, so usually values like salaries, it is very rare you see everything occurring like repeated values or something. So salaries and all, we just maybe for an illustrative purpose, you can have some values like you mentioned. But in general scenario, salaries are going to vary over a continuous range and hence you cannot consider mode or something. Okay. So yeah, so you depending on the data, you can decide. Okay.
But the TA is saying in today's session that the mode is the least affected by outliers.
Mode is least affected by outliers, not median.
No,
Yes,
in the
there is a
lecture also it is told that mode is least affected than median than mean.
no in lecture. Ma'am is telling that median is less affected, but the TA and there is a question in activity 3. I think their option also saying that mode is least affected.
But more or less mean is the highest affected.
Median is both
But
least affected.
But I guess there is some issue here. So usually, see why median is less affected by outlier compared to mode. That is something very intuitive, right? Can you say, first of all, what is median? Do you understand that part? If you understand that, then why I am saying median is less affected by outlier should be very clear. Can you tell why?
Ma'am, because of his position.
Exactly, that's it. Okay. See, what is median? Where are the outliers lying? So usually the definition of outliers, there is a specific definition of outliers. So you see, suppose this is your entire data set, let us say. So this is your minimum, this is your maximum, let us say. Your median is here. So that let us say this is your ordered data set. Ordered data set. So in this case, this is your median. Okay, usually, so here, let's say we have not yet defined what are these values. Later on, you will learn what are these. So your outliers are going to be somewhere here or here. So it will not even come closer to median. So the presence of outlier will definitely not affect the median at all. That's why median is more robust to outliers. Okay.
Ma'am, if you can check the activity 3 question,
Is it in
there
week?
is a option.
Is it in week
Oh,
3?
Yes, week 3, the activity 3.
Okay.
3.3.
So specific question doubts, can we do it maybe either on Sunday session or maybe if you have time at the end of the session, because we will not be able to complete the contents of this week otherwise. Okay. Specific
Okay.
question doubt, let's discuss it either at the end or on Sunday doubt session. Okay.
Okay.
Yeah. All right. So here, what
Ma'am,
is, yes,
excuse me.
yes.
Ma'am, in today's session, Aditya sir told that if we change the mode by ma'am, echo is coming.
What is coming?
Echo is
Okay, so just check if it is better now. Yeah.
hello.
Yeah. Can you
Yes,
feel
yes,
the,
yes. No
okay.
problem. I am telling that Aditya sir told that today in the morning session that if we change the values of the mode, then the mode will change. Means let us take that 2, 5, 3, 3, 3 and 9. Then their mode will be 3. And if we change to this to like if we increase 9 and if we decrease the all the values, and if we decrease all the values, then it would become the outliers as 2 because 2 is the least there. Therefore, mode becomes 9, but 2 becomes the outliers. Therefore, mode is least affected by outliers. He told that.
I don't know exactly. Is the notes available? I guess there is some misconception
No,
there.
no, he told today in today's session. This.
Let
But
me talk with the TAs. What did they discuss in the session? Let me talk with them. I guess there is some misconception. Okay. So
in ma'am's lecture, the ma'am is clearly saying that the median is least affected by outliers.
yes, that is actually the correct statement. Okay.
In the recorded lecture.
Yeah, so that is the correct thing. I guess I'll talk with the TAs. There is some confusion. Sorry that there was this confusion. So maybe the specific problems which they were discussing, I will tell them to discuss it again. And maybe in the doubt session on Sunday also we can discuss them again. Okay. So now let's come back to the topic here. What is median? First, let's try to understand. For many of you may not have first seen what is median. Okay, so median here is the of the data set is a number that divides the bottom 50% of the data from the top 50% of the data. So here, if you take this is the order data set, so you can see that this is the bottom 50% data and this is the top 50% data, and it is going to sit in the middle of these two. Okay, so how to obtain the median? So first step to always, whenever you see the word median, the thing you should remember is you should have an order. Okay, order is very important for median. Okay, Now let n be the total number of observations in the data set. If the number of observation is odd, yes. So if the number of observation is odd, then the median is the observation exactly in the middle of the ordered list. Okay, so for example, look at this case. So here your n is 7. So this is a odd number. So if this is an odd number, so first let's try to arrange the data in ascending order. If you try to arrange in ascending order, can you tell me what are the values?
45,
45,
45,
45, 55,
50,
50,
50,
55,
55.
50,
60,
55,
65, 70, 70.
60, 65, then 70, then 75. And 70 after that.
Yeah. Now to find the middle value, now what is the
60.
number of observation? Number of observation is 7. Now you see if
7.
the value is odd, then you should look at what is n plus 1 by 2. What is n plus 1 by 2 in this case?
Fourth position.
4.
Yeah. So you see,
8 by 2 equals to 4.
so median is the
Fourth
fourth
observation.
position. So if you look at what is the in the fourth position,
60.
60.
so this is the median position and the median value is 60. Okay. Now what happens in the case of even numbers? So if you have even numbers, you should find out the mean of n by 2 and n by 2 plus 1 observation. So for example, here look at this data. Now we are having ages of 8 people. Now here 8 is a even number. So here your n is 8 and 8 is even. So now let's arrange in ascending order. Can you tell the numbers in ascending order?
18, 20,
18, 22, 20,
18, 22, 24, 28,
20.
30.
Ma'am, 20,
20,
22, 24, 25,
25,
27, 28.
27, 28, 30.
30. Okay, so these are the values. Now in these values, now you have to see if n is 8, you have to look at n by 2 and n by 2 plus 1. Remember this 1 is outside here, not inside the fraction. So it means you are looking at the fourth and fifth position. Right? So what is there in the fourth and fifth position?
25
Ma'am, it would be divided by 2, right?
24.
Yes, so then you take the average value. So here you take the average value. So here you take the average of 24 and 25.
So, ma'am, for every even data set, we can take only 4th and 5th position.
For even data set, you have to calculate n by 2 and n by 2 plus 1. In this case, n is 8 and hence 4th and 5th.
Oh, n by 2 is 4th and n by 2 plus 1 is 5th.
Yes, in this case.
Okay.
Yeah.
Okay,
Okay,
ma'am.
so
Okay.
yeah, so finding median, is it clear for everyone? Can you try
Yes,
for
ma'am.
this data set? Can you all take your calculator? Calculate sample mean and median for both this data set.
Median is 7. Data set 1.
Ma'am, first one is 5.5.
Ma'am, mean is 5.375 and median is 5.5.
So note that there was some error, some unnecessary values were there. I have removed it.
Median is 5.5.
Okay.
First one.
Mean is 4.2.
So here the data set is if you are
Median is 7.
5, 6, 7, 7, and 12. So yeah.
Mean is 6. Right?
6.
Mean is 6.
Yeah. Now we
And
have
the second one, median is also 5.5.
okay.
Sorry, it will not be.
Median is 6 and mean is
21.
okay. So what is it you can see? Outliers. So here you see definitely this is an outlier. What is mean by an outlier? Outlier means it is a value in a data set that is very different from the rest of the data, right? So either it is unusually large or unusually small. So here this is, you can see that this is unusually large compared to the other data values. Okay, and hence this.
Yes, I am telling that only that the TA told that in the outliers, since 117 is an outlier, so its mode is very less. It has only one frequency, therefore mode is not affected by outliers. In case if we increase its mode, then say we eliminate all 3, 5, 6, 7, and in place of those we place 117 all and keep 2, then 2 will be the outliers. In that case, the data is being changed, therefore it will get changed. Therefore the TA told that mode will least affected.
So why 2 is an outlier? That part I did not get.
No, I am telling that in case if we remove 3, 5, 6, 7, 7 from this data set and we include in place of this which we eliminated in place of this, if we put 117 to all except in place of 2, we keep 2 and others we all keep 117, then in that case 2 will be considered as the outliers, no? Therefore, since that data set has been changed, therefore the mode is getting changed. And if we don't,
change the entire data set, that is different, right? You change
yes,
the entire
but
data
if we don't change the data set, then it would get least affected because 117 is outlier and its mode cannot be very large, like of 7.
See, when mode will be affected by an outlier, so mode will be affected by an outlier. Usually, when the outlier is itself a mode, in that case, the mode will be affected. Otherwise,
I am telling that only.
Yeah, so in the rare scenario, you will see that a mode will be affected when the mode itself is the outlier itself is the mode. Okay, but see, this is one
Very
possible
less
case.
probability, no?
Let me complete my statement. See, this is a possible case. But the thing is that median will never get affected by outlier. That you can say. Mode will be affected by outlier in certain scenarios like this, as I mentioned. But you cannot say any scenario where the median will be affected by an outlier. That is why median is more robust.
So, ma'am, in case you
Hello,
told
ma'am.
that if mode is equal to outliers, if mode is prepared by the outliers, then the outlier will change, no? If we increase in place of 7, if we give to 117.
You did not understand. Let me tell this scenario. What I am saying, let me give that scenario. So,
Hello, ma'am.
yes, can I complete this, what I'm going to say?
Regarding this, can you check? I send a screenshot in a chat section. Can you check it for it?
Just a minute, I will check after completing writing this. So, for example, let us say you are having something like this. Suppose you are having like this. Now, this is an outlier and this is the mode, right? Yeah. So now in this case, so the mode is affected by the outlier. So if I'm going to remove the outlier, the mode will get affected.
Now, hello?
Yes.
Now make another data set without repeating the outliers more than one, but with the same number of observations.
Okay.
Then
Just
I could able to understand you after
okay.
this.
Okay. Just a minute. I'm just reading this image. So adding a constant to each data point changes the mode. Mode is less affected by the outliers in the data. What is the last option? I could not see. So I guess this question is comparing mode and median. Sorry, mean, not comparing Mode and median. I guess this question context is comparison of mode with the mean when there is an outlier. Okay, for the one who sent the picture, maybe the question is
No, ma'am.
comparing.
There is a statement based asking for the correct statement.
That's what I'm saying. So here they are saying mode is more affected by the outliers in the data than the mean of the data is the first option, right? And the third option is mode is the least affected by the outliers in the data. So here in general, it should not be the case. Median is the one which is least affected by the outliers. But here this is most probably here the context is they are saying mode in comparison with median. Sorry, in comparison with mean. That's why this option C is expected. Otherwise, it is not correct. Median is the least affected. Okay, so please don't get confused. So there is a confusion, I understand. So let me just try to complete this part. Whatever the other person was asking me to do. Can you please repeat what you were asking me to do?
Ma'am, I am asking that make another data set without repeating 117 more than one time, then
Okay.
and keeping the number of observation as same.
Okay. Okay.
Yes, in this case 117 is outliers,
Yes.
right? And here the mode in this case, in the second statement, in the second line, you erase 6 and make it 2, let's say.
That's fine. That is from okay. That's not going to affect anything. Yeah. Anyway, for
Then in this case, what is the mode 6? No.
yes.
So here outliers is 117, but mode is 6.
Yes.
So it is least affected.
See, the thing is that we are talking about a general data set, not a specific data set. What I am saying, you should try to understand as follows. What I am saying is that I have a scenario where mode is affected by outlier. Correct? This scenario. Yes. But you cannot. So the next thing is that, but median will never be affected by outlier in any scenario. Whatever is your data set, median will never be affected by outlier.
Because of its position.
Yes, but that is why median is more robust. Okay, do you understand the difference now?
Yes.
Okay. Okay, so this is something everyone should understand. Median is more robust because of its position. It will never be affected by an outlier. Okay.
Ma'am, in the question that I sent, if there is a comparison, then it should be less affected, not least.
Correct,
I think
correct,
the
correct.
statement.
I agree. Okay, maybe I will note it down and maybe make a change to that question. Okay, so it is in activity. Which activity? Just let me note it down.
Activity 3.7.
Activity 3. Okay, question number 7. 3.3, question number 7. Okay, let me note it down. All right. Okay, so coming back to outliers here. So outliers, you see that they are unusually large or small values. The sample mean is sensitive to outliers, whereas the sample median is not sensitive to outliers. Okay, so you can see this from the above example here. Okay, all right. Now what happens to the median when you're adding a constant? Again, the same kind of logic. Suppose let us say the old median, sorry. So your old median, let's denote it. What is the notation we use in general for median? Any standard notation we have for medians? I don't think so. So maybe let's say that old median Old M. Okay, so the old median, how is it related to the new median? When you add a constant, it is simply
Add.
plus C, right?
Yes.
So for example, this data, if you arrange in ascending order, can you tell it in ascending order?
55, 60.
48,
Oh, 48, sorry.
55, 60, 63, 62, 63, 65, 67, 70, 72.
Okay. So what is the N here? Your N is
10.
10.
okay.
10.
N is even number. So we consider n by 2 and n by 2 plus 1th position. So 5th and 6th position. Right? So here 5th and 6th position is
62 and 63.
So this is the 6th. So here
123. 125, I think.
we are talking about median, right?
Yes.
So
125 by 2. Yes.
okay. And what is the new data set? We are adding 4 to each value.
52, 59,
59, 62,
62,
66,
66,
67, 69, 71, 74, 76.
So here, what are the 5th and 6th position?
66 and 57.
So these are the 5th and
66.5.
6th.
160, 174, I think.
Is 66.5, which is 62.5 plus 4.
Yes, ma'am.
Right? So your new
Yes.
median is old median plus C. Okay? Fine. Okay. So the same kind of scenario is going to happen for multiplication as well. Okay. So here in this case, so again, it is the same data set we have seen earlier. So what is the median of this data set? We have seen is 62.5. Okay. Now, if you multiply this with 0.3, your data set is going to become I'm writing directly the ordered data here. You can verify this.
$18.73.
So here you see the 5th and 6th values are these two. Right? So if these are the 5th and 6th values, your new median
18.7.
right? This is your new median. So you can see that this is nothing but 62.5 into 0.3. Can you verify this? So
Yes.
what is that you can see? Your new median is simply old median into C. So if your yi is xi into C, this is what is your new median. Okay, clear?
Yes.
Okay.
Yes.
Okay. So mode is the most easiest to calculate. So mode of a data set is the most frequency occurring value. If no value occurs more than once, then there is no mode. Okay, else the value that occurs with the greatest frequency is the mode of the data set. So we have the following examples here. So in the following example, in the first one, what is the mode?
A data set can be bimodal, multimodal.
Yes,
Like,
yes, there can be several
how
modes.
many modes can be there?
Any
At most?
number,
4.
no fixed
And
value.
mode is 4.
Unimode, ma'am, multimodal. Multimodal, ma'am.
Okay, just a minute. Yeah. So here, what is multimodal?
They mean several modes,
Yes.
More than 2.
Yeah.
more than 2.
So in this case, first example, what is the mode?
4, 7, 6.
Only 4,
Only 4.
Ma'am,
4, 4.
right? For 4, the frequency is 3.
3. 3.
Okay. So
3,
this
ma'am,
is
3,
one
sorry.
having highest
Oh.
frequency, hence this is mode. What about the second data set?
There is no mode. Right?
Yes.
No mode.
Okay, all are having the same frequency, so no mode in this case. Okay, now again for adding a data set, this is again very straightforward. What is the guess? What is your guess?
Plus constant.
So ma'am, it will be 6. Ma'am, old mode is 4, constant is 4, then new mode becomes 6.
Yeah, so in this case here, no mode, so this question does not make sense. So maybe you can consider this data set 4794, 674. That question you can consider. This question is not going to make sense for the mode because this is having no mode. So maybe you can consider the example 1 here. Okay. Similarly, for multiplication also a similar case is going to happen. So here old mode into 0 into C is your new mode. Okay. All right. Okay. So next thing is measures of dispersion. Why do we need measures of dispersion? Okay. So we have seen measures of central tendency. We know how to
Because
calculate.
of continuous.
Not continuous. So for example, you look at this data set. So data set 1, data set 2. Okay, so let's calculate the measures of central tendency for both these data sets. Data set 1, mean, median, mode, all are 3. Data set 2, mean is 3, median is 3, mode, there is no mode in data set 2. So just from measures of central tendency, I'm not able to say much about the given data set. So what is different? What is the main difference between data set 1 and data set 2? Okay, so to understand that these two data sets are different and how different they are, we need something called the measure of dispersion, which will help us to understand. So for example, to describe that difference quantitatively, we use the measure of variation or spread. Okay, so what are the different measures of variation or spread? It can be range, variance, standard deviation, and interquartile range. Okay, range is the most easiest to calculate. Just see what is the minimum and maximum, and that gives you the range. So here, for the data set 1, what is the range?
2.
0.
0. And for data set 2?
4.
4.
So from the range itself, you can see that the first value is not changing at all. The range is 0. It means the value is not changing anywhere. And for the second data set, the range is 4. So at least you can see that the value of the first and last value, at least there is a 4 value difference. So you can, from range itself, you can understand how different are the data sets. Okay.
Ma'am, I have a question.
Yes, yes.
Ma'am, can you write the question?
Okay. Specific questions, let's do it at the end because we are getting
No,
drifted.
for range only.
Yeah, for range only you are talking about a specific question. So let me just complete all the topics quickly and then I'll get back to your question. Okay.
Okay.
Yeah. Okay. So data set 1, what is the range here? 4.
4.
And data set 2?
That is 24.
24. See, there is one outlier, and this outlier, how drastically it is changing the range. So that is why range is very sensitive to outliers. Okay, so this value here is an outlier in data set 2. Okay, I guess later on you have some specific formulas to find outliers, but for now, just by observation, you can see that this is an outlier. Okay, and range is sensitive to outlier. Okay, what is the next measure of dispersion? It is variance. What is variance? One way of measuring the variability of a data set is to consider the deviations of the data values from a central value. So the central value we are going to consider here is mean. Okay, so here we see that capital N is the size of the population and small n is the size of the sample. So you based on those values of n and n minus 1. So the first formula we refer it to as population variance, and the second value we refer to it as sample variance. The difference here, you see the denominator in the population variance it is capital N, and in sample variance it is n minus 1. Okay, so here you see that suppose you are having this data, everyone please take your paper, pen, a calculator, everything you keep in your hand. So this data we have already computed the mean. The mean for this data is 62. Okay, so from here, what is the formula for computing the variance? This is the formula. So variance is summation xi minus x bar square. So this is the sample variance by n minus 1. Okay, so I'm going to use this formula to find the sample variance. So in this case, you see, I'm having, this is deviation from mean. So this is xi minus x bar. These are
So what
square
is the number of
deviation.
observation?
It's 10.
Okay.
N is 10. Okay, so in this case, do these calculations. So your x bar is 62. So what are the values?
7.
One last value is missing here. Okay, and then the square of these values. To calculate the sum. What is sigma xi minus x bar whole square? What is the total? Have you calculated?
Yes, ma'am.
464.
64.
464.
Okay, so now what is the population variance and what is the sample variance here?
Population will be 46.4 and sample by 9.
Is that correct?
Yes. Hello, ma'am.
Yes.
Yes, ma'am.
Ma'am, why in this sample variance we use n minus 1,
Okay, so
not
why?
the number of observation?
So you are asking about the formula itself, right?
Yes, yes.
Yeah, so this is an actually interesting question, but I guess uh,
Hello, ma'am.
I am just seeing. So I don't think I have just sufficient time to give the answer, but this is a very good question, and it is important to know also
Ma'am,
why it is n minus 1.
it
Yes.
was discussed today by Aditya sir. Sir told that to maintain the normality between the sample and the population variance, it is done by the what is some theorem is there. I think.
Yeah, so that's why I'm saying. So this is a good question, but in this time, I won't be able to give the entire answer. See, I don't know. There is some kind of I guess it's Bessel's some value.
Yes.
Yeah.
Yes.
So they
Yeah.
say some Bessel's error or Bessel's correction or something like that. So why?
Bessel's correction.
Yeah. So because of which we are dividing by n minus 1. So they call it because there is some degree of freedom difference is there. So we take n minus 1 instead of n. Okay. So I guess to explain it completely, I will take more time. Maybe we'll do the following. So if there is a specific video where this is already discussed, I will share that, or if possible, I'll try to discuss this during the doubt session. Okay. So it is definitely what to know the reason. Okay. All right. So, okay. So here, now if we are adding a constant, then what happens to the data?
No effect.
No effect, right? Why there is no effect?
Yes.
What is the reason you think there is going to be no effect?
Because the difference will be same. If you add then difference, the difference will be same.
Exactly. So you see that, so this is a very important property. You can see that. Okay. So I will leave the verification to you. So homework, verify.
Ma'am, is it because of squaring?
It's not because of squaring, it's because of the difference. You see here, you are having xi minus x bar, right? So suppose you are adding c, and then your x bar will also become x bar plus c. So what will happen to x bar plus c minus x bar plus c?
Oh,
It will be simply again x minus xi minus x bar only.
Samjha. Thank you.
Okay. Okay. All right. Okay. So same, what will happen about multiplying a constant?
C square into the old one.
Yes. There you have to be careful. Okay. When you are multiplying, it is different. Okay. Because if you are multiplying, then what will happen? So if you are, so this is while adding, right? But when you are multiplying, so when you are multiplying, what will happen? Your xi will become cxi. Your x bar become cx bar. So your xi minus x bar itself is getting multiplied by c. And so the squared deviations, it is becoming c squared xi minus x bar square. That is why your variance formula will change in this way. New variance equal to c square into old variance. Okay. Okay.
If
So
you can
this-
repeat that part, why c square?
Because here you see that this c is getting multiplied, and when you are doing the squared deviation, so this is your squared deviation. So the c will get squared, and hence the c squared will remain in front of xi minus x bar square. Okay, so you see when you are doing this formula, so the c square is coming in addition. That's why c square into old variance. Is that clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Okay. So again, this part, I'll leave it as a homework to verify. Okay. Is it okay if I leave it as a homework? Because just simple calculation only, right? You can try it, right?
Yes.
Okay. Okay. So the next thing is, what is standard deviation? Standard deviation is nothing but square root of the sample variance. Okay. So the sample variance is expressed in units of square units if original variable, square units of original variable.
Ma'am, it is the square root of the sample variance.
Yeah. So usually we see that standard deviation, why are we considering standard deviation instead of sample variance? Just to see the variation in terms of the original units itself. Because variance means the units are getting squared, but standard deviation, since we are taking the square root, the units are remaining the same. and hence many people use standard deviation as a measure of variation. Okay, no other big reason. Okay, and for standard deviation, again, a similar kind of change you can expect. So for adding or subtracting a constant, the effect on standard deviation is nil because of the same reason we saw for variance. And for multiplication by k, since we are taking a square root and we are having like c square multiplied or here in case it is mentioned as k. So if it is multiplied by k, variance will be multiplied by k square. And when taking the square root, you are going to consider the positive square root and hence multiply by mod k. Okay, fine. All right. So this is about standard deviation. Maybe there is one interesting question here which is not covered in this course, but it is useful to know. That homework everyone note down. So what is the measure of dispersion which has no unit? So at least this one you see there is some unit. So if you want to get rid of the units completely, so what is that measure of dispersion?
Which have no unit,
Sorry?
which don't have unit.
Yes. There is one measure of variation which has no units. Okay, and it has a specific purpose also. Why
I
it is?
think it's range.
No, range is obviously having the same units as that of.
Oh, yes.
Ma'am, can you repeat the question, please?
So there is a measure of dispersion which has no units, and why such a measure is actually important, that is also there. So for example, suppose let us say there are two shops, like two branches of the same shop. Let us say Apple showroom. Okay, so Apple showroom is there in all countries, right? So it is there in India, it is there in Europe, it is there in US, right? And all this Apple showroom, they want to understand how much is the sales varying in a month. Okay, so in India, they will give the values in terms of INR, in US, in dollars, in Europe, in some other currency. So in every place, the currencies are going to vary and the measure you are going to get in different units. Okay, so to avoid this confusion of units, there is something, a measure, okay, which helps us to get rid of the units completely, but still we can easily compare the measure of dispersion across different data sets. Okay, so try to figure out what is that called. Okay, so just a simple Google search will give you the answer. Okay, fine. So moving to the next important part here, what is called percentiles. Okay, understanding percentile is again important. In certain exams also your scores are sometimes given in terms of percentiles. So you should understand what is meant by percentile. Okay, all right. So
Is it remittance?
no. I don't know what is remittance anyway, so maybe it is
No.
a possible answer.
I am telling remittance means the foreign exchange.
No.
Coefficient of variance.
Yes, correct. It's coefficient of
Okay.
variation. Okay. So it is not just about money. So it is across many different things. Okay. All right. Yeah. So talking about percentiles, what are percentiles? How to understand percentiles? Okay. So percentiles, the sample 100p percentile is the data value having the property that at least 100p% of the data or less than or equal to it, and at least 100 into 1 minus p% of the data values are greater than or equal to it. What does it mean? Suppose maybe here, so the easiest to understand is the 50th percentile. What is mean by 50th percentile?
You are ahead of 58%.
Yeah, so you are saying that, so you are at least less than or equal to 50% of the people, and you are greater than 50% of the people. It's exactly in the middle, right? So in general, how to understand percentile and how to compute the percentile. So let's take a specific example to understand it more clearly. Okay. So to understand percentile, first thing is arrange them in increasing order. Okay. So this data set, you see that this is already in ascending order. So this is already in ascending order. Okay. So we don't have to do anything. And after that, if NP, so here N is 100. Okay. And then what is NP? You have to check. Sorry, not 100, 10. So you have to see what is NP. So the first case, P is 0.1. Right? If P is 0.1, your NP is 1. So in this case, your NP is integer. Right? So if it is an integer, then what you have to do? Then average of the values in positions NP and NP plus 1 is the sample 100p percentile. So here you see that what is NP and NP plus 1? NP is
35 and 38.
Yeah, NP is 1 and NP plus 1 is 2. So you have to look at the first two values. Okay, 35
What
and
is
38.
NP represent?
NP is just N into P. What do you mean by what is representing NP? The positions here we are going to see. So NP is the first and NP plus 1 is the second position. Positions we are checking.
Okay.
Okay. So now here you are seeing that the average of these two values. So 36.5. So that is your 0.1 percentile. So what does that mean? What does that mean? So here let's go back to this statement here. 100 into 0.1. What is this?
10.
10. Right? So this means in this given data set, 10% of the data is less than or equal to this 36.5. So out of 10 points, how many data values are 10%? In 10 data point, what is 10% of the data?
So
Did I ask?
35.
No, no.
35.
No. I try to understand my question. You are having 10 values. In 10 values, how many values are contributing to
Only
10%?
one.
Only one.
Only-
Yes, that
Yes.
is what I'm asking. Only one value is contributing to 10%. So you see that 36.5 is the 0.1, that is 10%. So you see that 10% of value, which is one value only. So only one value is less than 36.5 and the remaining 90%, which is this, is above 36.5. So what is mean by percentile? Is that clear to you? This definition, is it making sense to you now?
Definition is very confusing but understood.
Okay.
Here it is written that 100 of
Hello,
1
ma'am.
minus p. What does it mean?
Ma'am,
Yes.
ma'am, I
100
have
of
confused
1
this
minus
topic.
p.
Ma'am,
Should I repeat
I
the
have
definition?
confusion.
Yes. Tell
Ma'am,
me, what's your confusion?
ma'am, I have confusion in this topic. Oh,
What's your confusion?
percentile.
Yes.
Ma'am, scroll down.
Yes.
Ma'am, here my confusion is that P is given that 0.1 and NP is given 1. So 35 by 38 by 2, 36.5. Then how it is calculating that? It is my confusion.
See, the thing is that here, what is this 36.5 telling? 36.5 is saying that 10% of the data set lies below 36.5 and my 90% of the data set lies above 36.5. That is
Ideally, when we compute the percentile for say 10 percentile, then we do n into 0.1 and that's coming to first. So ideally it should be the first position, like 35. That is in the 10 percentile. Anything
Exactly.
beyond that is a 90 percentile. So
Exactly.
why we are computing the average 35 and 38?
See, the why this is because of, see, just like we are doing the median formula, why are we doing n by 2 and n by 2 plus 1 for even and n by 2, n plus 1 by 2 for odd, a similar kind of a reason only. So here, whenever we are having integers, we are able to do this. But whenever we are not having integer, we are not doing any such thing. For example, here you see for second value, now this 2.5, NP is 2.5. Now this is not an integer. In this case, what are we doing? Determine the smallest integer greater than NP. What is the smallest integer greater than NP?
3.
Yeah, so 3 is the smallest integer greater than 2.5. So here we have to consider the value in the third position directly that will contribute to the 100p percentile.
Actually,
Okay,
my confusion part is somewhere I'm okay with this. Like when we are doing even, then for the median we have to compute the average of fifth and sixth position, and then we can find the median. But when we are calculating the 25 percentile or Q1 or Q3, then why we are taking average? In some we are taking average, in some we are not.
the reason
That
is
part I'm
exactly same as the median. For example, this is the median value, right?
So
If
are
you
you
are
saying like with the n, if n are even, so we have n as even. So then then only we can do this n by 2 thing, taking the average and then computing the Q1 and Q3. And when n is odd, we can compute the value directly. Is that so?
exactly something similar. So here, for example, median, exactly that is what we are doing, right? Median means what we are doing. So here n is a even number, and hence what are we doing? We are considering the fifth and sixth position and the averages, right? So this is the 50th percentile. So the exact same concept goes for any value where NP, where that is not an integer. The exactly same concept. So you have to divide them in an equal proportion. So division is not possible in cases where the integers, where the NP values are integers, and hence we are doing the average to have an exact division in the kind of the exact point you want. So exactly after 10th percentile. Okay, whereas in the case of, for example, 25th percentile, this is exactly sitting in the 25th percentile position. Okay, so
Okay,
we
means
don't
you
have to
want
do
the
any
exact
prediction.
value.
Sorry, what?
We want the exact value, like the
Exactly.
exact point. Okay.
Exactly. Yeah, that is why we are doing this. Yes.
Ma'am,
Yes.
ma'am,
Hello?
I want to know that in first row you calculated 35 by 30, 35 plus 38 by 2, 36.15.
Yes.
And in the third row, 61 plus 62 is equal to 63.5 you have calculated.
Yes.
Average of two values from the
Yes.
data set.
Yes.
Why another row it has not been calculated?
That is what I was saying here. Why we did not calculate for others. Whenever there is an integer, we are calculating. But otherwise, we are not calculating. So whenever you have an integer, then you do NP, an NP plus 1 average. And for last value 10, you see that the last value already is NP. There is no NP plus 1. And hence, for the 10th one, you are directly writing 79. In all other cases, whenever you are having integer, this is what you are doing. Okay?
Hello, ma'am.
So, ma'am,
Yes.
if there is integer, so we calculate average by 2.
Yes.
Okay.
Ma'am, I have a question on why 100 into 1 minus p, what does it mean?
Why? Sorry, what?
No, what does it mean for 100 into 1 minus p, which
Yeah.
is given in the statement at the
Yes.
first?
So that is what I explained here. See, for example, if p is equal to 0.1, what is 100p? This is your 100p. So if p is equal to 0.1, 100 into 0.1 is 10 percentage. And what is 100 into 1 minus p?
0.9 into 90%.
That is what you're saying. So your 36.5 divides the data set. So whatever value is less than 36.5, that is only 10% of the data set. And everything above 36.5 is contributing to 90% of the data set. Okay?
Got
Hello,
it.
ma'am.
Thanks.
Hello,
Okay.
ma'am.
Thank
Yes.
you.
Yes.
Ma'am, here the percentile is given and we collect this, but for a given data, how to collect the percentile?
This is the exact procedure I'm saying. So you calculate, so whatever is the p value, you calculate NP depending on what is your n. So if your NP is integer, follow the third step. If your NP is not an integer, follow the second step. That's all. There is nothing much you have to worry. Okay, if you do few examples, definitely you are going to understand it yourself. Just you follow this formula, you will get the answer. You just calculate NP and then apply this formula here given in step 2 and 3 based on it is an integer or not, you will get the answer. Okay. So here quartiles, what are quartiles? Quartiles, you see the 25th percentile is called the first quartile, 50th percentile is the median or second quartile, and 75th percentile is the third quartile, right? So what are we basically doing? So if you are having this is the data set. So this is your minimum, this is your maximum. In the middle, you are having the second quartile, right? And here in the middle of minimum and Q2, you are having the first quartile. And in the middle of median and maximum is your third quartile, right? Q1, Q2, Q3. Okay, so here you have 25% of the data, 25% of the data, 25% of the data, and 25% of the data, right? So it is very easy to visualize, right? Q1, Q2, Q3 is dividing the entire data set into equal parts. Okay, and that is the 5-number summary. Minimum, Q1, Q2, Q3, maximum. So this is your 5-number summary. Okay, so the interquartile range is nothing but Q3 minus Q1. Okay, so IQR for the example. So here maybe just one small example if you are taking. So here, if you are considering this example here, okay. So here for this data, what is your Q1 and what is your Q3?
Just a request, if you can
Q1 is
take a fresh
47.
data where,
This is
sorry to
Q1 is
disturb.
Q2,
47.
Q3.
Yes.
If you can kindly take a fresh data where n is even and n is odd, two data, and do the
Okay, you want another data set? Okay.
fresh data with where n is odd and also where n is even.
Okay, so let's take a very small data set. So 3, 5, 7, 9, 10. Okay, a small data set. So here n is 5. Okay, so what is the median in this case? So median is the, so maybe we'll calculate minimum. Minimum is 3 and then we will calculate Q1. Q1 means your P is 0.25. If P is 0.25, what is NP? Calculated. Yeah.
1.25.
It is
1.25.
1.25. If it is 1.25, is it an integer or not an integer?
No, it should be between 3 and 5.
No, this is not an integer, right?
It is should be 2 then.
Yeah, if it is not an integer, you consider the next highest value, which is 5. This is the second position. So
okay,
2 is the next highest integer. So you consider the second position. So second position, so you have Q1 is equal to 5. Okay. And then for Q2, you take P is equal to 0.5. And so your NP here is
7.
Yeah. So again here, what is NP first of all?
2.
NP is 2.5.
Third
So
position.
2.5. So you consider the third position. So again, third position you have Q3 is equal to,
7.
sorry, Q2 is equal to 7. Okay. So then again Q3, your P is 0.75. What is your NP then? What is your NP?
3.75.
0.75 into 9. So 6.75, right? Or did I do anything wrong?
0.75 into 5, right?
5. Yeah.
3.75.
Yeah, sorry. 3.75. So you consider the fourth position, which is 9. Right? And then you know what is the maximum. So this is your 5-point summary. Okay, and what is the IQR in this case?
Q3 minus Q1.
which is 9 minus 5, 4. Okay, why IQR is required? Why not just range is sufficient? So this makes IQR is more reliable when there are outliers, because you see that range is very much varying based on outliers, but IQR is more stable when there is an outlier. Hence IQR is preferred over range when there are outliers. Okay. So I try to cover all the topics from week 3, and apart from this, if you are having any specific doubts, we can discuss it on Sunday
But
doubt session.
in here, in this
Yeah.
case,
Yeah.
you have taken where n is odd, like sorry, when n is even, there are 10. So for n P1, you did 35 plus 38 divided by 2,
Yeah.
the average.
Yes.
In this case, we are calculating like the first position, it won't be enough, right?
See, you are looking at what is NP. You are not worrying whether n is odd or even is not our concern. Our concern is whether NP is integer or not. That is what we have to see. Okay, n can be even, odd, anything. But what is NP is what you need to check.
Okay. If NP is an integer, then we get the value, right?
If NP is an integer, you just have to do the average. If NP is not an integer, you just directly take the value in the next position. That's it.
Got it. Got it. Sorry.
Ma'am, I want a clarification regarding a doubt. Could I
Regarding
ask?
specific question,
No, I want to make you a question and want to ask it.
okay, so that is a specific question only. So, and now already we are running out of time in today's session. Shall we discuss it on Sunday doubt session?
Okay, okay.
Ma'am,
It is
what
for
will be
range
your
only.
Also,
To find the range.
if I may ask, where I can find the recordings of previous sessions?
So it is there in the YouTube live streaming. It is going on. So it is available in the YouTube playlist. You can see, or if you YouTube playlist is available for everyone, right? So that is not a
If
problem.
anyone can share the playlist on the chat, that would be helpful.
Ma'am, what about the
The
PDF?
IIT Madras
PDF is
BS
available in the
YouTube
supplementary
channel.
content of the
Ma'am,
course
but
page.
in my portal only week 1 is available right now.
Actually, there are a few recordings from the previous year also. So that is why
Let
I
me
am
let me
confused.
share the playlist also here, and the drive link also. Just give
Yeah,
me
that
a
would
minute.
be helpful.
Yeah, just a minute. Let me share it. So the PDF link, actually someone asked in Discourse also. I have posted the Discourse link. But anyway, here also I will post. Just a minute. Looking for the link. So only my lecture notes is there so far. I'll add today's notes also in the same place. So the chat, this is the Google
Ma'am,
Drive.
can you share the Discourse link also, please?
Just a minute. Okay, so this is the Drive link. Okay, and the Discourse. So Discourse post is just having this link, so there is nothing much. But let me first share the
Ma'am, the
YouTube
drive
playlist.
link is asking for access request.
If you are opening it from the study mail ID, it should not have any issue.
Ma'am, I don't have my study mail ID right now.
Okay.
Ma'am, this course is only for, I know that it is for foundational level students. Hello,
Okay.
ma'am.
Yes. Just
Ma'am, can you scroll to last page of
I'm
the
updating the drive access. Just give me a minute, please. Okay. So I have added the given access to everyone for the drive, and for the playlist, I'm going to paste the playlist. Just a minute.
Ma'am, you will upload the week 2 and week 3 PDF in the drive after this?
Week 2, I don't have because I did not handle the session. Week 3, yes, I will add the
Hello,
PDF.
ma'am. Will you take the
Ma'am,
doubt session?
ma'am,
I'm not
I
sure whether I will take the doubt session, but anyway, if not me, then the other instructor will take, not the TA. The other instructor will take. So here is the YouTube link for.
ma'am, I am facing the problem or the issue for accessing the lectures from the portal itself.
You have
After
to write.
logging into,
You have to send a mail to support.
I have already sent it them, ma'am. It's been a week, but they haven't responded till yet.
Can you CC both the instructors? At least CC me so that I will see what's the progress. Okay. All right. So this today's notes I am going to add. I guess. Okay. So whatever you
Ma'am,
have
can I have the
asked.
mail ID for
Yes.
CC?
Yes. Just a minute. The chat I'm putting my mail ID also.
Hello, ma'am.
Yes.
Ma'am, for a competitive exam like JEE or anything, the percentile they calculate by using this method. The how they ordered, there is many sample like many students.
They take the middle list first.
Sorry, what?
Sorry, they take the marks first and multiply it with the number of observations.
Oh, you
How
are
they
asking.
ordered?
Okay, you are asking. I was not concentrating properly. What you were asking, I was typing here this mail ID. Okay, so I was thinking you are asking about the syllabus, some question from the syllabus of entrance exam. Okay.
No.
Okay, so you are asking, so how are they using percentiles to calculate marks for competitive exams, right? So here the
Yes, yes.
data set is going to be the marks of all the students. Okay, and then whatever is the number of students who appeared in the exam, so that is going to be your N, and whatever percentile, so your data value, whatever percentile is going to appear is based on the N and the value your score. Okay. Yes, so here I have added the link of the Google Drive, YouTube playlist, and my mail ID. And now I am going to add this particular
Discord
session.
playlist, Discord link.
Okay, so
Ma'am, Discord access is only given to foundation level, sir, and maths instructor session has said that.
I am foundation level student.
yes, just a minute. The discourse post I'm looking for. Just give me a minute. Discussion forum discourse.
May I leave now?
Yes, those who want to leave can leave. Specifically,
Thank you, ma'am.
discourse post. Yes, it's here. Yeah. Got it, pasting it in the Zoom chat. Okay, and today's notes also I'm uploading it in the drive. Okay, so thank you everyone. Please check this links I have given here. We'll see you again in other sessions. Thank you. Bye.
Thank you.
Thank you for
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.